Hi students, welcome you back. And in this video or in this session, I am going to take permutations and combinations. Okay, so in this video we shall discuss the multiple choice questions of permutations and combinations so that you can also get some idea of solving the problems on permutations and combinations. Okay, so here you can see the first problem, that is there are 5 doors there are 5 doors there are 5 doors to a lecture room. The number of ways that a student can enter the room and leave it by a different door is. Okay, so there are 5 doors to a lecture room. The number of ways that a student can enter the room and leave it by different door is 20, 16, 19 and 25. Okay, so here you can just see a student can enter the classroom in 5 ways. The student can enter the classroom in 5 ways, because see here there are 5 different doors to enter the classroom. Okay, so if the student has to enter into the classroom, he has got 5 choice: 1, 2, 3, 4 and this is 5. So totally there are 5 choice for a student to enter the classroom. Okay, so once he come inside the classroom you take through this door, so this choice is over. Now how many are remaining? 1, 2, 3 and 4. Only 4 doors are remaining for him to go outside. So see here there are 4 ways to leave the classroom. 4 ways to leave the classroom. So therefore you can just see that the total number of the ways is 5 into 4, that is 20 ways. Okay, so that means there are 20 ways for a student to enter the classroom and leave the classroom in the different doors. Okay, that means the door through which he is coming, he is not going through the same door. He can go with other different doors. Okay, so there are total 20 different ways. There are totally 20 different ways. So option 1 is going to be the right answer. Okay, so you see here, that means he has got 5 choice to enter the classroom, and if he enters the classroom with this door, now he can't use this door to go outside. Okay, so he remains with only 4 choice. So therefore 5 into 4, that is there are 20 ways. There are 20 number of ways to complete this experiment. Okay, so therefore option 1 is the right answer. Clear? Okay. Now let us go for the second problem. See that the value of 1 plus 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus so on to plus n into n factorial is, see, we know that n into n factorial means the formula is n plus 1 factorial minus n factorial. N into n factorial means the formula is n plus 1 factorial minus n factorial. Okay, so now using this you can say that 1 plus 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus so on to n into n factorial is nothing but 1 plus 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial plus 4 factorial minus 3 factorial plus so on plus n plus 1 factorial minus n factorial. Okay, so that is nothing but your n plus 1 factorial. Okay, so if I simplify this, I am going to get nothing but n plus 1 factorial. Okay, so here you must know what is factorial. Factorial means, here you can see that n factorial means 1 into 2 into 3 into so on to n. Okay, so next n plus 1 factorial means multiplied with n plus 1. Are you clear? So n into n factorial means you can just write it as 1 into 1 plus 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial so on. On the same way, n plus 1 factorial minus n factorial means you can write 1 plus 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus so on to n into n factorial. So that is going to be nothing but 1 plus 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial plus 4 factorial minus 3 factorial plus so on to n plus 1 factorial minus n factorial. So therefore n plus 1 factorial is your answer. Okay, so therefore option 3 is the right answer. Option 3 is the right answer, that is n plus 1 factorial. Okay, so now quickly we can move for if 9p5 plus 5 times of 9p4 equal to n 10pr, then what is r? Okay, so for this you must know the standard formula of permutations, that is n minus 1 pr plus r dot n minus 1 pr minus 1 equal to n pr. Clear? So therefore that is, here you have 10, here you have 9. This is n, this is n minus 1, this is n minus 1, and here this is r and this is r minus 1. Okay, so now they are asking about r. What is r value? Okay, so you can just say that npr, r value is nothing but here 5. Clear? So that's why this particular formula is going to be very, very important. Okay, that is n minus 1 pr plus n minus 1 pr minus 1 equal to npr. So this is going to be very, very important formula. So therefore here r value you can just see, that is 5. Clear? So therefore option 1 is the correct answer. Okay, so the problem looks very simple, but here this is very, very important, that is the required result. Okay, now we can go for the fourth problem. If 56pr6 is to 54pr plus 3 is equal to 30,800 is to 1, then r is 17, 38, 41, 52. So here just you can write using the formulas, that is 56 factorial divided by 50 minus r factorial multiplied with 51 minus r factorial divided by 54 factorial equal to 30,800. Okay, so now if I simplify this, here you can just see, you can write this as 50 minus r into 50 minus r factorial into 51 minus r. So therefore 50 minus r factorial, 50 minus r factorial will get cancelled. Here 54 will get cancelled. So 55 into 56, here 51 minus r will be equal to 30,800. Okay, so now if you simplify this, you can just see 51 minus r equal to 10. Okay, so now 51 will be equal to what? Sorry, you can just see 51 minus 10 will be equal to r. So that is 41 will be equal to r. Okay, so option 3 is going to be the right answer. Clear? So while solving this particular step, you have to be very careful. Okay, use the factorials correctly. Once you use the factorials correctly, then you are going to write the correct answer. Here 51 minus r factorial can be written as 50 minus r factorial into 51 minus r. On the same way, 56 factorial can be written as 55 into 56 into 54 factorial. Okay, so now this 55 into 56 will remain as it is. 54 factorial will get cancelled. 50 minus r factorial will get cancelled. So 51 minus r will be multiplied with 56 into 55. So therefore r will be equal to 41. Okay, so option 3 is going to be the right answer. Option 3 is going to be the right answer. Okay, now let us go for the fifth problem. That is NPR equal to 3024, then N comma R is 4, 9, 9, 4, 9, 6, 6, 9. So now you see the result. NPR is equal to 3024. Now NPR can be written as N into N minus 1, so on into N minus R plus 1. So that is going to be equal to 9 into 8 into 7 into 6. Okay, so now comparing on both sides, you can just see here N will be equal to 9 and R, that is last term. Okay, that means you can just see N is 9 plus 1 is 10. Okay, so minus 4 will be 6. Clear? So therefore N minus R plus 1 must be equal to 6. So for that reason N is 9 minus R plus 1, so 10 minus R equal to 6. So 10 minus 6 will be equal to R. So R will be equal to 4. Okay, so N is 9, R is 4 is the required answer. That is 9, 4. 9, 4 is the right answer. Clear? Okay. So now you can go for the sixth problem. That is the number of ways in which 5 boys and 5 girls can be arranged. 5 boys and 5 girls can be arranged in a row, so that no 2 girls are together. Okay, so here you can just see no girls are together means you have 5 boys. So for that, see the arrangement, no girls are together, 5 boys can be arranged in a row. First it can be done in 5 ways. See here, this is boy 1, boy 2, boy 3, boy 4, boy 5. Okay, so now I will place, this is G1, this is G2, G3, G4, G5. Okay, 5 girls can be adjusted here. Clear? So 5 boys can be arranged in 5 factorial ways. Clear? On the same way, you can just see there are 6 places for the girls. One is here 1, 2, 3, 4, 5 and this one is 6. Okay, so this is the 6th place for the girl. Clear? So girl have 6 different all the 5 girls have 6 places. Okay, so 6 places for 5 girls, and you can see 5 places for 5 boys. Clear? So totally 5p5 you can write it as 5 factorial. So 5 factorial into 6p5, that is 5 factorial into 6 factorial is going to be the right answer, that is option 2. Option 2 is the right answer for the required problem. Clear? Okay. So I think this can be easily understood by everyone because very simple problem. Okay. So as you understand the problems, as you understand the concepts, you are going to get the confidence. So that's why now we can move to the next question. That is the number of ways in which 6 boys and 5 girls can be sit in a row so that no 2 girls and no 2 boys are together. No 2 girls and no 2 boys are together. Okay. So arrangements you can see here. 5 girls can be arranged in a row in 5 factorial ways. And you have 5 places for the girls and 6 places for the boys. Okay. So now 6x can be filled in 6 boys in 6 factorial ways, 5 factorial ways for the girls. So therefore the number of ways are 5 factorial into 6 factorial. Clear? So that is option 3. Okay. Now let us move for the 8th problem, that is, see, there are 25 railway stations between Vijayawada and Mumbai. The number of different kinds of a single second class tickets to be printed so as to enable a passenger to travel from one station to another station is, see, there are 25 railway stations between Vijayawada and Mumbai. The number of the different kinds of the single second class tickets to be printed so as to enable a passenger to travel from one station to another station is. Okay, so total there are 27 stations because Vijayawada and Mumbai also has to be considered. Okay, because in between there are 25 railway stations. So Vijayawada 26, Mumbai 27. So there are total number of 27 stations. So now you can just see what they are telling, the number of different kinds of single second class tickets to be printed so as to enable a passenger to travel from one place to another station is 27p2. So that is option 3 will be the right answer. Okay. Clear? So therefore option 3 is the right answer. Next, the number of ways in which 20 white balls and 19 black balls be arranged in a row so that no 2 balls of the same color come together is. Here you just see there are 19 black balls that can be arranged in a 19 factorial ways, and there are 20 white balls. So for them you can just see this is the place for the white balls. Okay, so there are 20x places for 20 white balls, so they can be arranged in 20p20. So 20p20 is nothing but 20 factorial, and 19 black balls means 19 factorial. So 20 factorial into 19 factorial will be the required answer. Okay, so that is option 2 will be the right answer. Okay. So here 19 black balls can be arranged in 19 factorial ways, and in between them there are 20 white balls, so that can be arranged in the 20 p2 ways. So therefore 20 factorial multiplied with 19 factorial will be the right answer. So now you can just see the next question. M men and n women are to be seated in a row so that no two women sit together. If m is greater than n, then the number of ways in which they can be seated is. You just see here, m is greater than n. That means first we should adjust this n places. Okay. And the next thing will be having n plus 1 places here. These things are going to be n plus 1 ways. So therefore n into n plus 1 factorial, n factorial into n plus 1 factorial will be the right answer. For that you can just see, no two women can be sitting together. No two women can be sitting together. M men can be arranged in a row. M men can be arranged in a row with m factorial ways. There are m plus 1 places to be arranged for n women. So it can be done in m plus 1 pn ways. So therefore m factorial m plus 1 pn factorial will be the right answer. Okay. So m factorial into m plus 1 pn factorial will be the right answer. That is option 3. So sorry, option 4. Option 4 is going to be the right answer. Clear? Okay. So in the previous problem also you can apply this, where there are 19 black balls and 20 white balls. There also you can just go through it, no problem. There 19 factorial into 20 factorial we have done. So here also you can go through the same conditions. You will have m factorial into m plus 1 pn factorial for the 10th problem. Okay. So now let us go for the 11th problem. The number of permutations of 8 different things taken r at a time is 1680. Then r is, so see here, 8pr equal to 1680. So 8 into 7 into 6 into 5 gives me 1680. So therefore you can just see r will be equal to 4. R will be equal to 4. Okay. So therefore 4 is the right answer. Okay. So that is 8 factorial 8 minus r factorial. Clear? So therefore 8 minus r factorial. 8 minus r factorial means 8 into 7 into 6 into 5. So see here, I has to cancel the remaining 4 factorials. So for that 8 minus 4 I has to write. So you are going to get 8 divided by 4 factorial. 8 factorial divided by 4 factorial. So now this will be converted into 8 into 7 into 6 into 5. Okay. So 8 into 7 into 6 into 5 will be the right answer for the 11th problem. So that is r equal to 4. R equal to 4 will be the correct answer. Okay. Clear? So that is option 4 is the correct answer. Now we can go for problem number 12. That is A, B, C are the 3 persons among 7 persons who speak at a function. The number of ways in which it can be done if A speaks before B and B speaks before C is. So these are the 4 options, and now you can just see the given persons other than A, B, C can be arranged in 7 places. So that is 7p4, because there are 7 persons. So therefore you leave A, B, C. Okay, A, B, C are the 3 persons among the 7 persons. So who can speak at a function? The number of ways in which it can be done if A speaks before B and B speaks before C. So now here 7p4 will be the places for 7 persons to talk, and for ABC you can just see 7p4 will be 840, okay. So therefore 840 is going to be the right answer. 840 is going to be the right answer. Clear? So ABC are the 3 persons among the 7 persons who speak at a function. ABC are the 3 persons among the 7 persons who speak at a function. So the number of the ways in which it can be done if A speaks before B and B speaks before C. See here, A speaks before B and B speaks before C. Okay, so total now you have the 4 places. Okay, so therefore you can just take 7p 4 ways. Therefore 840 is the right answer. Okay, for this 840 is the right answer. Clear? Now let us go for 13th problem. The number of ways in which the candidates A1, A2, A3, A4, so on to A10 can be arranged in a row if A1 and A2 are next to each other is 9 factorial into 2 factorial, 10 factorial, 10 factorial into 2 factorial, and 9 factorial. So A1 and A2 are next to each other. That means A1 and A2 must be together. Remaining things can be arranged randomly, no problem. So they are considered as one object. Okay, so they are considered as one object. The remaining 9 things can be arranged in 9 factorial ways. So total there are 10. Now A1 and A2 considered as 1. So now they are converting to 9. So 9 factorial ways. And the remaining A1 and A2 here itself, A1 and A2, here I can arrange A2, here I can arrange A1, A1 and A2. These are the 2 ways. Okay, that is 2 factorial. Therefore 9 factorial into 2 factorial will be the right answer. That is option 1. Okay, so option 1 is going to be the right answer for problem number 13. Clear? Okay. So second question, you can just see A1 is just above A2. Then the number of ways are, see, A1 is just above A2. That means they have only one choice. A1 and A2 are considered as one object and the remaining are 8 objects. So 9 factorial ways. Here A1 is always above the A2 means there is only one way for that. Okay, the second way here A1, A2, A2, A1 are the 2 choice, but this is not considered. They are telling A1 must be always above the A2. So therefore it is only one choice. Therefore 9 factorial into 1 is again 9 factorial. So option 4 is going to be the right answer for this particular problem. Clear? Okay. Now we can go for the third problem. A1 is always above A2 is. So already it is over. A1 is always above A2 is. So here they are telling A1 is just above A2. A1 is just above A2. And here they are telling A1 is always above A2. So therefore in this particular cases, please remember always above means other candidates A1 and A2 can be arranged in 10 places. See, other candidates other candidates other than A1 and A2 can be arranged in 10 places. Okay, so 10p8 ways. So A1 and A2 can be arranged only in one ways. So therefore 10p8 will be the right answer. Okay, so 10 factorial and 10 minus 8 factorial. So that will be 10 factorial divided by 2 factorial. 10 factorial divided by 2 factorial will be the right answer for the given question. Okay. A1 is always above A2 and A2 is above A3. So for that you just see other candidates than A1, A2, A3 can be arranged in 10 places. Okay. So 3 are not considered. So remaining 7. So therefore 10p7 will be the total number of arrangements, because A1, A2, A3 are considered as one object, but here there are total 10 places where A1, A2, A3 are having the restrictions, other 7 are not having any restrictions. So 10p7 can be written. Okay, so 10p7 means 10 factorial divided by 3 factorial will be the right answer. Okay, so here you just see the word, that is A1 is always above A2. A1 is always above A2 and A2 is above A3. A2 is above A3. Okay, so please go through this problem very carefully. Very important problem, because this is having 4 different problems: always above, just above, and is above, and again A2 is above than A3. So that's why please be careful. So this problem is going to be very important. Take care of it. Okay, so fifth one also you can see, if A1, A2, A3 are sit together in a specified order is, because A1, A2, A3 are considered as one object, so remaining 6, so therefore there are total 7 objects. Okay, so because total A10 means 10 objects, in that A1, A2, A3 are considered as one object, so remaining are 6 objects, so the remaining are 7. So now 7 plus 1, that is 8, total number of 8 objects. So 8 factorial ways will be the right answer. Okay, so here 8 factorial ways will be the right answer for problem number 5. Clear? Okay. So now let us go to the 14th problem, that is 3 men have 4 coats, 5 waistcoats, 6 caps. The number of ways they can wear them is. So now you can just see 3 men can wear 4 coats in 4p3 ways. Okay, 3 men can wear 5 waistcoats in the form of 5 3 ways. So next 3 men can wear 6 caps in the form of 6p3 ways. So therefore 4p3, 5p3 and 6p3 will be the right answer for this particular problem. Okay, so that is 4p3, 5p3 into 6p3 will be the right answer. Clear? So 4 coats for 3 men, so 4p3, 5 coats for 3 men, 5p3, 6 caps for 3 men, 6p3. Okay, so 4p3 into 5p3 into 6p3 will be the right answer. Clear? Okay, so thank you students, and we can continue the remaining problems in the next session. So let us meet in the next session and let us continue with problem number 15. Clear? Okay.